Hi everyone, I'm Matteo Colantonio from GARR, the Italian National Research and Education Network. And yes, today I will going to talk about our journey to automate our optical network. So a journey that starts with some stumbles on familiar tools, and then takes a significant turning point with the discovery of this workflow orchestrator framework we will see in the second part of this talk. And finally, I'll show you how we have implemented this framework to automate our optical network. So let's dive in. As many, we started looking at most used and widely adopted tools. That is Ansible. Some of our colleagues used it in other domains successfully, so we thought, okay, why not? And it did work. We upgraded all of our transponders of this particular type you see in the picture with Ansible. Actually, we used also AWX to have a nice UI to schedule the upgrades out of the normal working hours. However, we soon realized that Ansible has limitation, and that is it doesn't scale very well in complexity. So simply calling one function in a loop that all it does is to restart one card. Basically, you have to nest one inside the other 3 YAML files with the include statement and keep track of all the register variables. Not to mention the fact that in the optical layer, some devices don't really support completely netconf, and you have to develop your module because it's not there. And this is an example of a TL1 interface for a device that we have. It's a kind of a CLI, but really structured, and it's imperative-only command. So, yeah, good luck having idempotent models with this type of interface. So, lessons learned. The complexity of Ansible project is really low if you have only simple procedures to do, and that is maybe pushing configurations to devices. But it quickly scales up as you want to handle real-world complex logic of configuring services, not only boxes. And maybe you will end up, if you stick only to Ansible, second-guessing some of your life choices. So in the meanwhile, we also looked at the vendor controllers API, that is the northbound interface, and seemed a reasonable option since they're the one building the devices. And the goal here is to automate the provisioning of optical circuits. That is basically the Ethernet line for the routers on long-haul distances. This is something that takes manually between 40 and 50 clicks across different graphical user interfaces. This is something that is a bit of a difference between managing the packet layer and the optical layer. The optical people are really used to graphical tools, and this will this is a unique starting point, or a different starting point, because we are not so focused on command line interfaces. So it kind of worked in one case. You cannot do the full provisioning, only line to line from remote transponders, but it didn't replace all the clicks we had to do. So we still had to perform some manual configuration before the provisioning. We still had to do the cross-connection on our transponder cards, and also fix non-meaningful names, because the operation teams needs services labels and description, which were never taken into account by the northbound interface of the controller. And to make matters worse, actually we don't only have one single optical line system. In some part of our network we have two, and if that's the case, you cannot do anything with the controller's API. So what we learned can be a bottleneck to your automation ambition. You are not really in the driving seat, because any bug, serious bug or feature request will take weeks, if not months, to be implemented. So we decided to use devices interfaces instead to get the full features, exactly the same features we get with the GUIs. Okay, so this is the turning point in our journey. We discovered this framework. Is a suite of softwares developed initially by SURF, the Dutch National Research and Education Network. And with the ESNet, they open sourced and registered this program in the Commons Conservancy. You can take a look at the link later on. And it allowed other organizations to adopt this framework. You can see some of them behind me. So Geant and Ceanet, they are part of the program supporting this framework, and recently we also adopted it. So what do you get out of the box? Well, it's a framework. So it doesn't do anything. It's not a turnkey solution, but it enables you to define your network services and entities, and these are called products. Basically, these are the domain models for your organization. Track individual customer instances of those products. These are called subscriptions. And define clear procedures, workflows, for creating, modifying, validating, and terminating these subscriptions. So it comes with microservices in mind. So the basic implementation you can have is a backend written in a fast API and a customizable UI. And also, everything is stored and tracked in the database. So there is an ORM, object relational mapping, and you can audit basically everything you ever done on with this tool. Okay, nice words, but let's see what they are in for real. So how do you define your reality? You have to define your building blocks. Here an example is a building block of an optical fiber that has a fiber name, has an operation system support identifier, and most importantly has terminations that are 2 ports. And these 2 ports are another block. So these are composable like Lego blocks. And then if you want to manage the life cycle of some of these blocks, you turn them into a product. So you just wrap an optical fiber block inside an optical fiber, then you can manage the life cycle of an optical fiber. Workflows then makes things really happen. So we saw your data model. than how you make changes actually in the network. So workflows are just a list of steps that are Python functions. And since it's Python, you can basically do whatever you want. The most complex logic, it can handle it because it was created for this. Here is an example of a workflow, sequence of steps. Maybe you want to reserve some resources on Netbox, just an API call. You want to confirm patching from a user, so you ask for the input from a human. You want to check the reachability of the node that has been patched. And then maybe you want to configure it using a configuration manager. So you trigger the start of the configuration, and you wait for the callback from the configuration manager. And finally, maybe you want, or maybe not, enable the monitoring based on some other function that performs some checks. And maybe enable monitoring is a group of steps, so you can combine multiple steps into one to get executed as one. So the aim here is to write code that does not collapse under the pressure of real-world provisioning and service management, that doesn't involve only devices, but also external systems, like IPM, IRM, OSS, BSS, and also, of course, keeping humans in the loop. All right, let's look at our implementation. So I said it took us 50 clicks, and this is actually the UI of one of these workflows that creates the optical digital service, as we called it. And here is the duration on the left. If you sum it up, I didn't make it up. It takes now 50 seconds. So this is not just a marketing slide. It's a representation of what the feedback from the operation team will be. I had people coming at me like, man, this is crazy, it's fantastic. It took me 15 to 20 minutes to do this. Now it's like 1.5 minutes. So it really pushes people. It's not pushing. It's like people want to use it because it makes their life easier. So was it easy? No, definitely not. It's not as easy as getting started with Ansible, but for sure it was worth it. We get central definition of our services. We get consistent execution of the entire lifecycle management. We get visibility into the state and the history of each service, and also toolkit for future services. And hardware can change, but our services, our models, and our workflow stay the same. So how is it actually this possible? Well, I already told you about these building blocks. So this is what we have done for our optical network. We have one consistent and coherent architecture of our building blocks that it's aligned with our mental models because we define it. Okay, so we have the POP, and we have an optical device that is in the POP, the optical port, and so on. And this is all hardware, let's say, and on this part you get the services. So an optical spectrum, then you have optical channels that travel in this spectrum, and services that are transported by these optical transport channels. And to you might ask then, well, you have one single optical device, but you have transponder, ROADMs, you have inline amplifiers, so these are all different. How do you manage the differences? Well, this is a characteristic of the optical device. Like, they have a type, they have a platform of the device, so you can, for different devices, like Flex ILS or G30, different platforms, you can define different client that takes care of translating your abstract intent into the device configuration. And if one day a new hardware comes in, you just have to define your client without modifying anything about your models and your workflows. So how do we make this happen? The problem is we have the same task, different platform. For example, you may want to set the admin state of a port to up for all the ports that are terminating a specific optical fiber. Then the idea is to use one function with multiple implementations for each platform. So you can do this in many ways, and we took the idea from the single dispatch approach used in Python. So somewhere else in the code, it looks like this. You basically just add a wrapper to the function, set a port admin state, and you register the specific platform. So Flex ILS, and then another platform. Same arguments, different implementation depending on the device type platform. Sorry. So the benefits is it keeps the code organized. It's easy to add new platform, and it really simplifies the workflow logic. And then we had another problem. We saw that the northbound interface actually results in a loss of control or functionality, while Ansible for the optical layer doesn't really work that well. So it just adds complexity. It really felt like sometimes we were fighting the tool instead of it helping us. So the idea is to, as I said before, communicate directly with the devices, like any other system with an API. And we aim for simplicity and maintainability of the code. So let's see one implementation of the function we saw before for a specific platform. Okay, here the port name is just a string, so we have to take out shelf ID, slot ID, port ID. Then we call a client we define, we developed. In this case, a RESTconf client. In this device, we find the port we are looking for. So this translates this Python notation, all dots to the RESTconf URL. Then we want to modify the state. You just type port.modify and set the admin state to up, which translates behind the scenes to a patch method with data validation, which is quite easy actually to implement in Python. And finally, we return the state of the port after modifying it with the get method. So when a new platform comes in, we use the same approach. And I hope you can see how readable, human-readable this is. In my point of view, it's far more readable than any Ansible task. So, and that concludes our implementations, some takeaway messages. If you want to develop a solution that is scalable and maintainable, I think the best option is to go with abstract and composable models and to use stateful instances of these models and stateful procedures. If you want your network to be programmable, then why don't use the API of the devices and not only relying on the configuration lines. If you want a sustainable transformation, then aim for to automate one service at a time. This is crucial for the people developing the tools, but also for the people using this tool, because it nudges people to adopt your tool because you are making their life easier. And with that, I conclude. So thanks for your attention if you have questions.
Thanks, Matteo. We've got time for a couple questions.
Yeah, thanks for the presentation. I had one question on your data model. Did I understand it correctly that you build it yourself, the whole data model? And if so, are you willing to share such that maybe other people can potentially reuse some of the, let's say, your mental model or your data model that you have been using inside of your application?
Okay. Yes, we built it ourselves. We defined our model that really fits our organization, our goals as an organization. And yes, we will, in the future, I'm not sure how far away this future is, open source part of this code. But the good news is that this framework is open source, and other organizations, such as Giant, already open sourced their models. They are using it for the packet layer. So maybe it's something even closer to your need. I don't know.
Oh, over here. So thank you so much for the talk. Quick question, just when I was looking at the Workflow Orchestrator core and all that initially a year ago, it was a little bit daunting to get started. Do you have any pro tips for anyone, when they want to get started with this project and make it work? Like, it doesn't seem to be like a one-click easy button, right?
Yeah, that's the easy no part in the presentation. So there is a Discord server. You can join and ask questions. Also, if there is any problem with the demo of the orchestrator, there is a demo that should work right out the box from on GitHub. I think it's good to open an issue or just drop a message on Discord. And the other thing is it's a kind of a trick. It's not how you should usually do things, but yeah, if you want to reverse engineer this software, the nice thing is that it fits inside the million context window of the latest models. So you just can put in the context, okay, give me a tutorial on to do this, and it most probably gets it right.
Hi. Over here on the other side.
Yeah.
So I do work on an optical network, and this is going to be very interesting for me, but is that orchestrator pretty much hard-coded to build optical networks, or could you re-engineer it to build other kind of networks as well?
No, it's not for optical networks only. It's people have used mainly. I mean, we are the first using for optical network. Other organizations, Surf, Giant, ESNet, they are using HNet. They are using it for the packet layer, and but it's so flexible that you could use it also in data center networks. And it's really flexible. So yeah, it doesn't do anything out of the box, but if you spend a little bit and invest a bit of time, then at least you don't have to start from scratch.
In your journey, you started with Ansible, you got away, after you tried with the controller, didn't work out, really painful. And after you propose that, now my question is, the controller, it's used by admin usually in the day-to-day because it provides a view out of the your whole ecosystem. What's the place of this controller? Is it completely gone, or do you still have it? Is it synchronized? What's at the end of the story? Where is this controller?
Okay, we still use it, but in its graphical user form. So the NBI, the northbound interface, we found out it has only very few functionalities of the graphical counterparts. Okay, so basically we are not using the northbound interface anymore, but we are still using it as a graphical interface.
Thanks, my name is Martin, and thank you for this really interesting insight in the process, or in the journey you did. You said if you spend a little bit of time, then it's possible. So can you elaborate a little bit more on how long this time lasted for you? So to get from the CLI up to that process?
To give you an idea, we work as a team of 2 people. One is my colleague Filippo, who is also here. He worked on the deployment aspect, so Kubernetes, microservices, on this stuff. Everything I showed you, I did myself, and we started in November. I think with the first proof of concept, it took me 3 months.
Hi. So quick question. As part of the lifecycle management of your subscriptions, how do you guarantee that the infrastructure stays up to date with the subscription desired state? Are you rerunning that workflow periodically?
Okay, I got lifecycle management, but I don't know. I didn't understand very well your question.
Yeah. So when you deploy your workflow, so as part of the workflow, you define the state that you want your infrastructure to be. So how do you handle the cases where, for unknown reasons, the configuration changes and the workflow has already run?
Okay, so there is a validate workflow that runs on schedule, and it checks the configuration. If the configuration has changed unexpectedly, it will put your subscription, so your service, out of sync in the Workflow Orchestrator. You cannot do anything more on the Workflow Orchestrator for that service. It's kind of locked until you fix the thing on the device, on the system, so that it is back again in sync. So if you have an emergency and you need to do something manually, you can do.
Awesome. Thanks, Matteo.
Thanks. Oh, almost forgetting. Almost forgot.